Okay, well, let's talk about data governance then. We have a very limited audience, so we can really tune it to our audience of, well, I know everyone except 2 people, so. I want to talk about data governance. Data governance is something that is so important to me that I wrote a book about it back in 2009. Data governance is about managing data within a corporation. So how can you effectively run a corporation, move data around, do profiling, do standardization of data? How, with doing that, how can you improve the business aspects of a corporation by managing data properly? And so we're going to talk about that with this slide deck, the data governance imperative. So for our agenda today, we're going to talk about corporate growth and data, and how corporate growth has an impact on data, both how it really plays no part in an early corporation, but later on will have a really big impact on data. We're going to talk about how bad data happens, so what things happen within a corporation that will allow you that make for bad data. We're going to talk about the butterfly effect of data quality, so sort of a little bit of chaos theory and data. And then we're going to look at open source solutions versus traditional solutions for fixing data quality and governing data. And then a little bit on Talend and some of the solutions that we offer. So I work for Talend. I'm the product manager for data quality, and I've been in industry for quite a few years. I'm out of Boston, Massachusetts. I have a blog, datagovernance.blogspot.com, and again, I wrote that book back in 2009. So let's talk about the business drivers and data and how they kind of relate. So if you look at this chart, on the x-axis I have system complexity. When you're a small company, you have pretty simple systems. Maybe you might have an ERP system or a CRM system. You might have a customer list. You might have a billing system. Really, when you're a startup company, the system complexity is very simple. Aren't too many databases within your corporation. But as your company grows, you do tend to add more and more. So let's say now we're no longer a startup, we go national. Now we need to have sales offices, satellite offices in various places. We need to add to the complexity of our data. And so more and more systems start to appear, ERP, supply chain systems. You may also go global. And so now you're opening up ERP, CRM systems in France and Germany, UK. The whole architecture of your company gets more and more complex as you grow. All along, you're really not thinking about data complexity. All along, you're really thinking about, well, how do I make more money? How do I improve my bottom line? How do I make my products better? Not necessarily thinking about data. But then as part of your growth strategy, now you acquire another company. So here comes company B now, and we have to manage all of their data in addition to our own growth, right? So a merger comes along. So through this, someone then at some point says, well, what did we sell yesterday? What do we have in inventory? Who is our best customer? They have questions that they have about business things, really important business things. And it's all contained within this data. But if you have these disparate siloed data sets, how can you pull it all together? How can you make this happen so that you really get the answers that you want? And that's really the challenge behind data governance, solving all of those issues, pulling all of those together. So what do? The solutions to this is they have all those data sets. First thing they do is they might hire an MBA to handle it. So they hire an analyst. And that analyst then has to go to all of those data sets and manually do extracts. They have to keep track of all of those data sets. They might need data quality dashboards to understand what's in there and profile and pull those data sets out. So they hire an analyst. It may take that analyst a couple of months to get answers about who the best customer is, what they have in inventory. Not really a very effective system. So the second thing they do is they build the data warehouse. And in that way, they do nightly extracts. They pull all these data sources down into one source. And they use Talend or some kind of data integration software to pull all of those together. They may also want to keep track of those data sources nightly, so they use regular profiling to identify issues within them and kind of do all of that things. But still there's more they can do. For example, if you have a lot of CRM systems spread throughout your company, you might want to consolidate those systems because the answer, who is the best customer, really might be contained within 3 or 4 CRM systems within your company. What do you have in inventory might be in 3 ERP systems within your company. So we want to consolidate those systems and really get them, get that information into one source. And the way you do that is with data integration and data profiling. You move that data into one source. You keep track of those separate systems by profiling. And then finally, generally there's some big advantages, by the way, to do that. Finally, what they do is they might do something like master data management, where they actually create a centralized repository of data and then manage that for master. So there's things like being able to share data between your ERP and supply chain system, moving the data back and forth, having this kind of data conversation that goes on within the application. So master data management is kind of the next evolution for that. So these are the types of solutions that they need. In the commercial industry, these are really expensive solutions. So what we're bringing to the market is an open source solution, open source solutions around these types of answers to the problems of corporate growth. Okay, and that's what Talend does, and some other, also other open source data integration companies. So let's take a look at what is bad data. Bad data might have things like this in it. So the first one is nicknames and abbreviations. My name is Steve, but I might be Stephen or Stephen with a PH. Here we have John, Jack, Jonathan, etc. So it's only in the US, by the way, that we do these nicknames. In other countries, they don't really do this as much. But in other countries, they have other data challenges. Like in Asian countries, they have things like first name and last name commonly reversed, right? In other countries of the world, they may have very long names where the child takes the parent's mother's name and the parent's father's name, so you get a very long name. Those are some of the issues we have to deal with. Incomplete addresses, so here we have 25 Main. Is it street, is it road, is it Ave? We have things like a broken data model. So this is a really common one when you have old DB2 and mainframe implementations. I have Steve Smith, and I have what looks like a tax ID number after that, right? The reason why they did that was back in the old days, it was really hard to change the model of your DB2 database. Nowadays, it's pretty easy to change that model, but back in the mainframe days, it was pretty hard. So how do we take that and extract those 2 pieces of information that's in one column of data? It's really important to do that because if we were to send a mailing out and it said Steve Smith and had his tax ID number on the outside of the envelope, it would be a big problem for us, right? We wouldn't be able to comply with the law, and the customer certainly would get irate. Then we have common reverse names. Things like dates are always a challenge. We have data shapes, so you can enter a phone number in a variety of different ways. We have null values. And then the final one is unstructured data. So I have this field that's called notes. And in the notes, it has things like, I have a 5/16 inch open end wrench, and I have a wrench, comma, open end 5/16 inch, right? Now we know as humans that those are the same thing probably, but it's really hard for a computer to understand that those are the same things. So we use things like standardization and parsing to parse those out, and then matching algorithms to put those together and identify the linkages between that. And what we have also with data as it kind of flows through a corporation is we have a butterfly effect of data. If any of you are familiar with kind of chaos theory around data, chaos theory in general, I should say, there is this thing called the butterfly effect, right? And so simply put, if you want to predict the weather, You have a butterfly in Africa, he's flapping his wings, he's sitting on a flower, and causes a little pollen to stir up. That pollen gets on the nose of a gazelle. The gazelle then sneezes, which causes gazelles to start jumping around and stirring up dust on the African plain. And then that dust changes the weather, right? So that's the chaos theory that you have. So it's really hard to predict the weather because small things can make big changes in the data, big changes in the prediction. So data has the same type of thing, right? We have, here we have what seems to be a pretty simple campaign. We're going to take some data, customer data. We're going to do a campaign. We're going to expect from that campaign some responses. So I'm going to try to sell to my customer base. Maybe I have a new product that I want to promote. And that also comes back, and hopefully if the campaign is successful, you get orders, and that goes into your order entry system. From that, there are shipments that go out. So now your shipping data has to be accurate. If it's an expensive product, you might issue credit and have to bill people after the line, so that goes into your credit issuing system. There are deliveries that have to be made, so it goes into your delivery system. There's the US team did this campaign, but now, okay, Europe comes along and they want to replicate that same campaign. And their orders now will go into the order system. Very interesting. So you can see data is very pervasive. Maybe as a result of that, you get some complaints, some additional support requests. There are things that might kind of sit outside there, and so you think, well, there's no real relation between sales and the general ledger system within our corporation. But then again, at some point, someone wants to get information about this. They want to do market research and see what's more effective. Is doing a mailing more effective than making a phone call? So you do some marketing research. Now they need to pull those sources together, right? So you can imagine if you have bad data starting at that original customer plan, the original customer database, the data quickly gets permeated throughout your entire corporation. So there are also kind of different things that happen because of bad data as it goes throughout your corporation. So first, if I have bad data in that customer database, I'm not going to be able to reach that customer. I'll have an email address that's bad, I'll have a shipping address that's bad, and I won't be able to hit that customer. If I have bad data then is permeated through to the order systems, I'll have high shipping costs because I'll get a bunch of stuff back, and I'll have missed shipments. The customer will be expecting it to arrive at a certain time, and that'll be missed. If I get to the billing system, I may issue credit to customers who are risky, credit risks. And I may deny good customers because I have bad information in my data. So that gets permeated. I may give poor customer service because if I have a call center, I may have various records of a person online, and that could lead to poor customer service. I may have bad or inaccurate business intelligence. I may not be able to deliver orders if I have a really poor inventory system. My data is messed up in inventory. It may say that I have the inventory I need to create my product, but if that actually doesn't exist in the warehouse, then I'll have a problem.